Okay, so we're still on means, but now we're doing confidence intervals for a difference in population means. This is different than the paired t interval, which is for mean differences. This is a difference in the population means. Here's the homework. Okay, conditions, exactly the same. So no real change there at all for this guy. Recent college graduate considering a job offer that allowed them to live in either New York or Chicago. To help make the decision, they want to estimate the typical cost of living in each city. That's smart. Here are the data on the monthly rents in dollars for independent random samples of 10 one-bedroom apartments in each city. So mu1, or I might call that mu New York or NY, population mean monthly rent of a one-bedroom apartment in New York City, and me2, or maybe mu of the CHIC or Chicago or something in the denominator in the subscript, the population mean monthly rent for one bedrooms in Chicago. Check if the conditions for constructing 99% confidence interval are met. Okay, so we're doing 99% confidence level. You might want to write that down. So first one is a random sample. So we got random samples of 10 in each city. So make sure you talk about random samples of 10 in each of the two cities. So don't just say random sample, but there are two different random samples, one in each city, one in Chicago, one in New York. Less than 10%, so 10 is less than 10% of all the one bedrooms in each of those respective cities. And then finally, we need to check the conditions. So is there 30 there? It looks like no. It's just n is 10, so that's not big enough. So I think we're going to have to, this is the pain. So you got to type in all the data first. So go to your list and spreadsheet. So at the home key, go there. I'm going to call this one New York. And this one I'm going to call Chicago or something like that, Chick. Okay, just type in the data for me. Oh, it's always nice when you don't have the right number of data pieces. So the fifth one, 1, 2, 3, 4, 5, should be 2,400. Another 2,400, I missed that. Oh, so this is important. You have to have the order. No, you don't. You don't, because we're not pairing these up, right? So the order, it doesn't, I'm going to put 2,400 at the end. It doesn't really hurt me because we're not subtracting each individual piece there. This is not paired data. We didn't pair these up, right? So we're just putting in the 10 pieces in any order really you want. So I'm glad that happened. So I can talk about that. It's a really good idea. It's not paired, right? Okay. So we've got all the data in there. So let's graph some box plots here. So, or we don't really need box plots. Probably a dot plot would be fine. So I'm going to do the first one, which is New York. And then I'm going to go menu. I think I can add an X variable. I'm going to do that. Number 5. And I'm going to add Chicago. Okay, so New York is up top, Chicago's down low. Whew. Man, it's not that skewed. I'm okay with that, but it does look like there could be an outlier. So let's just double check plot type box plot. Looks okay. So it is a little skewed, but not majorly skewed. So I think we're okay there. So you're going to draw both those on the on your paper, either the dot plots or the box plots or the histogram if you'd rather. So really you have to draw both graphs on your paper. They don't have to be side by side. I mean, you can put them next to each other or on top of each other like that. But you need to draw both graphs, I believe. So let's see what they did. they checked, they said for the normal large sample, so 10 is less than 30, so that doesn't work. But they showed the graphs and they said, well, they're a little skewed, but not majorly skewed, and there are no outliers. So that's good. So you can do both graphs in one. I like that idea as well, with a dot plot or a box plot there, kind of like the calculator did. Again, that's the reason we think that the population could be approximately normal. Here's the formula. So pretty similar to what we've done before. Differences there is your statistic. We think the null is it's going to be 0, right? No difference. T star, and then you're kind of a weird version of original standard deviation. It's weird because everything's under the square root, but that's how we roll with this one. So it is on the formula sheet, at least that part the standard error is. Yeah, that part is on the formula sheet, then the generic kind of interval thing there. Okay, so they're saying we can do the whole test in the calculator. Well, let's do that. So if you do the whole test in our calculators, go to calculator page, not a scratch pad, menu 6, 7, and this is a 2, oh wait, we're doing interval today, sorry, menu 6, 6, and we're doing a 2 sample T interval, right? So not a Z interval, this is about means. So that's it. We are using data. So we have lists. List 1 is, I think, New York. List 2 was Chicago. Oh, I think it was at the 99, wasn't it? I forgot to change that. I'm just going to change it in the thing. Okay, so that should be our answer there. So lower and upper negative 77.7 to 951. Wow, that's not what I expected there. Let me see if they came up with the same. Yeah, that's what we got, right? I think that matches exactly. X1, 2025, yeah. Standard deviation is 430. Yeah, everything is the same. Okay, so we did it correctly. So then you do the do section. I think they're switching gears here on that one, but I just probably like to finish it. So so the do section, we're plugging into that formula, right? So you would plug in the values from this guy. So x1 minus x2, so 2025 minus 1588 plus or minus t star. I think you'd have to do that one. So that would be inverse t of, let's see, that if it's 90, just make sure it's 99%. 99%. So if it's 99%, you put 0.995, because that's the part to the left of that, comma degrees of freedom, which is 9, I believe. Wait, let me just double check something. 2, 3, 4, 5, 6, 8, yeah. Okay, so then you type in 3.25 for your T star there. Standard deviation, again, is listed S1, S2, so 439.697 squared over n, which is 10, plus 350.414 squared over 10, and all that square rooted, and then you'll get your answer. And actually, honestly, it's not a bad way to do it. Some people just don't even do one variable stats. They just go, I'm going to do it in my calculator. It's getting all the data to plug in. I need to plug in those guys to make your work look really good, right? Okay. As the Spanish-speaking population in the United States has grown, businesses have increased their focus on both English and Spanish options for customer service. One study interviewed a random sample of customers leaving a bank. Customers were asked if they spoke English or Spanish when talking to the bank representative. Each customer rated the importance of several aspects of bank service on a 10-point scale. Here are the summary. So here's the stats, so to speak. Calculate a 95% confidence interval. So again, you're going to plug in, first you got to state, assume the conditions are met. That's so nice. Okay, so we're just going to go right to the, I still think you probably need to do the null and alternate. They didn't do the null or the alternate. Let's see, so the null would be, the difference is a 0. The alternate, maybe? Oh, man. Are they saying, it may not make a difference for the questions they ask here, but it seems like they're saying that English is about to become less popular, that maybe Spanish is more. I'm not sure. I guess it's not part of the question. Probably shouldn't spend too much time on it. It wasn't written clear enough to know. So you're going to plug in that formula. So again, you're going to, well, they told you those things, right? Or most of them. T star you'll have to get by, no, it's 95, so 0.975, comma. Oh, this one's interesting. So what do you do for degrees of freedom? Because they're different sizes. Let me look back at that last one. Well, let's look at the calculator. Degrees of freedom is, oh my goodness, 17.1. I didn't catch that. So why was that last one 17.1? So let's look at that data. Degrees of freedom is weird on this, right? So you expected it to be 10, right? But you're not really pairing it up, but you expect it to be 10, both individually 10, but it's 17.1. So in this one, I would let your calculator cook. I would let your calculator do this for you. There is a formula for that, man. We don't want to know that formula. We don't want to even think about that formula. So they haven't mentioned degrees of freedom yet. Let me just make sure I didn't miss it. Okay. So T star, you almost want to do this in your calculator first to figure out T star. To figure out the 143.69. Let's see if we get the same answers when we do it in our calculator. I like this idea. So let's just play here. So menu 6, I think we're doing an interval, and this is a 2-sample T interval, I believe, and we are going to use stats. So x1 is 6.37. 6.37. It's tab. Standard deviation is 0.6, and it's 92. X bar 2 is 5.91, 0.93, and N2 is 86. I think it was 95% confident if I'm right. So they got 143.694. Is that? Yeah, that looks about right. And they gave you the interval as well. If you mouse up, it's 0.226 to 0.693 there. Good. Does the interval we just found provide convincing evidence of a difference? So they are just saying the alternate's a difference there. So is 0 in the interval, right? 0 is the null. We think there's no difference. But it does look like if you do English minus Spanish, you get positive outcomes because all the positive values in the interval are positive. So if it's English minus Spanish, that means the mean reliability rating. I didn't realize it was about reliability ratings. And so again, we have to calculate that degrees of freedom because 0 is outside the interval, right? We do have convincing evidence because 0 is not in the interval that there is a difference in the population mean reliability ratings between the two. Oh no, changing food size portions would influence subjects' food consumption 1 day later. Assigned to 2 groups, with one group being served small portions, the other one large portions. Oh, I know which group I want to be in. The next day, all the customers were allowed to serve themselves, and the research showed how much food they consumed. I actually think this is interesting. So, okay. Construct and interpret a 95% confidence interval for the difference in the mean amount of food to be consumed the next day by people like the ones in the study, or so forth. So state, be sure at some point to indicate the order. I think I would do large minus small. And that's what they did, 95% confidence interval. U of subscript large is the true mean amount of food that would take consumed in grams the next day by people like the ones, and mean of small is the true mean amount of food who takes, etc. Name the test either by name or interval. And the 3 conditions are randomly assigned. Oh, so this is an experiment, right? So some people got the small, some people got the large, but they were assigned those treatments, right? So this, you don't need to check the less than 10% condition. The large sample, since n is bigger than 30, it does for both of, you have to check both because it's going to be good. You don't have to check the 10% condition because it's an experiment. So if you plug into the formula, you get something like this. You kind of have to wait on T-star until you get the, in fact, I would just get it from the calculator, right? So let's just do this one in the calculator and get it from the calculator. You can actually get the T-star value, I believe, from there. Let's see. So you're going to go menu 664. Definitely not data. We have stats here. X1 is 144.66. Variation is 72.36. And then 38 is the sample size. X bar 2, 189.91. 55.62. And 37. 95, I think, was correct. Open. Let's test this out. Let's see. Oh, I wonder if I did it the opposite way. So I got negative 74 and negative 15. I think I did the first one minus the second one. I meant to do it the other order. The only difference in my answers, you'll notice, is mine are negative, right? Because I did it in the wrong order, or at least not what I thought I was going to do it in. So I really kind of messed up there. But notice the degrees of freedom, hard to calculate by hand. You want to let your calculator do that for you. Because again, the calculator output, it has degrees of freedom somewhere, DF, 69.301. It also has T, I believe. Well, it's just, sorry, so lower bound, upper bound. We don't need T for that one. Okay, I think that's the lesson for today. If you want to do an extra problem about chubby bunnies, that's a pretty good problem. There's your answers for those two, and this one as well.